Okay, thank you.
All right,
All
now
right.
conclusion.
All right. So good evening, everyone. Hope you all are having a great week so far. So today's webinar is going to be focused on your first assignment, which is specifically on the first part of your assignment. And although some detailed description of each step is provided in your instructions, in the assignment instructions, both Yelena and I, the thought of reaching out to you and to walk you through the each step of this part one of your assignment, and also try to answer any questions that you may have, or help you with any pain points that you may have so far. And I see that some of you have already started working on it, which is it's a great sign, and I'm glad that you have already taken that step. So this 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 webinar is not going to be like focused on your part two, but as I said, it's part one, and what you may see here is as I said, it's already covered. But we'll kind of try to make this a little more interactive, and this is all about you. So feel free to chime in. We don't want this to make it as a presentation kind of webinar, but as a webinar where you can ask your questions, get it answered, and get some value out of it. Okay. So with that, let me dive into the agenda. And during this walkthrough, if you have any questions, please type in the chat window, and we'll try to unmute you. Or if you've already typed in your full question, I'll try to answer as we go along. Okay. If not, we'll definitely have a Q&A towards the end. So the agenda, as you can see here, we want to just go through some tips for success in this course, and it's not just for this particular assignment. We'll just once again go over some R environment steps that it's already mentioned in your in instructions. We'll just kind of go over that, show you different ways to do it, and I know Yellen already did a great job kind of showing you and walking you through the R Studio and R. But this is just going to be like a quick refresher again. Then we'll go through some assignment one steps, and then once again open it up for your Q&A, and we'll wrap up. Okay. So hopefully we should be here. I mean, we should be done within an hour or so, or maybe an hour and a half. That's what we expect so you to be here. But if you're done earlier, that's fine too. Okay. So tips for success, practice with different data sets. Can't stress this enough that, working with multiple or many data sets, of course, not as part of your assignment, but, if you have worked with a data set in the past, try something new. These assignments are, just for you to kind of try with different data sets and learn about what are different challenges. So don't just go about, if you've used a data set in the past, just pick it up and turn it into an assignment here in this course. Trust me, that's really not going to help in your learning process. Secondly, know the tools. Very, very important. Knowing your environment here, whether it's R Studio, and then later in the course when you go through the Bluemix platform or working through PySpark, make sure that you kind of are very familiar with the tools and how it works, and feel free to play around it, right? I mean, don't not just stick to the instructions provided. Just play around with it. Play around with all the different parameters that could be there for each of the commands that are part of the instruction set, or that you may be using for your assignments. There's a nice help feature on your packages or functions that you installed, or the way to, even if they're not installed, there's still a way to kind of find out about certain packages or certain commands. So use that help feature, and it's a great help feature that you have there. And understand and try different parameters, as I said, for just see the impact of results. What happens if I use that? And then even you may not know what that parameter is about to begin with, But sometimes the results itself kind of tell you a lot about it and kind of give you all the explanation and understanding that you may need about each of the parameters. Next, don't be satisfied with bare minimum. Never ever. That's the end of your learning if you do that. Um, just try to start working on it early. And I see many of you already have, so it's a great job with that. Keep up with this, right? Keep up with this attitude. Make sure that you have enough time towards the end to work more on your assignment. See that whatever you can give more, give some better problems for your instructors and your TAs in terms of when you're turning in your assignment, that you kind of worked on some more than it could be expected or desired. Read an internet for problems and issues, new features and techniques. Having said that, both Yelena and I are here to kind of help you. And we are on the discussion. Please feel free to post your problems or anything that you may face. But having said that, make Google your friend. There's lots and lots of stuff out there on the internet. And if you're stuck at, let's say, 12 o'clock at midnight or 1 o'clock at night, what do, right? I mean, you want to just take help from, maybe by, just Google your problem, try to see if there's somewhere that's kind of solved or mentioned about. And if you can have, form, study groups here within your classmate, with your classmates here, and within your class, if you can have a nice study group, excellent idea. I love that idea because, group study is really going to be very powerful, very helpful, as long as you just do not copy, things with each other. That's really not going to help again. So, use that and build some good programming habits. Some of you may already have a good programming background and, may have already started to work on these habits and maybe at a point where, you already established that. If so, very good. If not, still not too late. Find out about what are some of the standards and conventions. Like any language, any programming language, even R has got a nice standards and conventions that you can start working with and practicing. And that's just kind of provided that link here that you can go to, see some of the conventions that are being used. And start with a skeleton template, right? Anything that you work upon, start with a nice template of all the steps that you would work on. It could be as simple as, loading the data set, doing some pre-processing, building your model, evaluating your model, submission or anything that may be required. All these steps, just few steps that you can just put it out there so you do not, lose out on anything or miss out anything towards the end. And then our studio itself provides a nice sections feature that you can make use of. You can have sections within your code that can help you build this template. And at the same time, it helps you kind of navigate through your code very easily, especially when your code starts growing, longer and larger. I mean, it becomes very easy to just navigate through, whichever sections that you want to go to. Even executing your code, sections wise, it becomes very easy. So that's some tips here that I as a student kind of found it very helpful. And I know it's been we found this it's from other students as well that it has been very successful. So just few tips here, and you may have some of your own as well. Share it with your friends, share it with your class, and make sure that everybody's successful here. But just keep working on and building some good habits. So before moving on, let me stop here to see if there are any questions before we kind of go deeper into our webinar here. Any questions from anyone? Okay. So next we'll go over our environment setup here. So which you're probably already familiar. Just a couple of ways as to how you'd find out about the R version, R Studio. And I know at times you have a particular problem that you're looking for, and then you may be going into and trying to see as to why certain package, certain functions or commands have given as an issue. And the first and foremost, the first thing that you want to do is find out about the version of R that you have, the version of R Studio you have, and for that you can either use an r.version command, or you can use a version function here, which will kind of give you some more information. So just some of the ways and techniques or certain commands that you want to really know very well, since it's going to be useful. Next, view available packages on CRAN. There are thousands of packages that are already made available to you on CRAN and that you may want to use of. Sometimes you may not be aware of all the packages, and that's fine. I mean, every day there's new packages that come up, packages that get updated, newer versions coming up. How do you really keep up? There's really no shortcut for knowing all those packages. But one of the ways that I kind of have found to be useful is once in a while, whenever you got like when you're starting to work on a new assignment, just go and type in a few search keywords in on CRAN and see what are different packages available. If I were you, I would just type in text. Just type in text on CRAN and see what are all the packages that have got in their description have mentioned text. And sorry about that. So the shiny server sometimes after some few minutes of inactivity, it kind of just dies down. So I have to just bring it up again. So these are some of the ways to kind of know about some new packages, some newer versions of packages that may be out there. Okay, and one of the ways that you can get onto CRAN is browse URL command. So just wanted to mention it here. But having said that, you can still be out of your RStudio environment. You can be on a browser and just type in that same URL. Use that same URL to go to different packages that are out there for your version of R. So the version of R is going to be the key here, and that's the reason why we kind of started with knowing how to learning how to find out about the R version. The next thing is to other questions that often get asked or we have to really dig into is what are all the installed packages that are available on my PC that I've already downloaded or have been downloaded automatically by when you're installing certain packages. And there's a simple library command that you can type on your console of RStudio to find out all the list of packages that are out there that have been already installed locally on your computer. The next is also there's a search command. If you just type in search, it lists all the loaded packages that you have. So one give you all the libraries and packages. The library command kind of give you a nice window there and all this list of libraries. The search command gives you the list of all the loaded packages. Okay. Next is in installing and loading packages. So there are two basic commands here. One is library, where you would kind of load a package that has already been installed, and as Yellen had mentioned, and it's also that described and mentioned in your assignment document is how to install packages. Use the dependencies flag. I know in the newer versions of R, like R3.4, the dependencies flag is already set to true, but it doesn't hurt to have that flag all the time so that you know that while you're installing a particular package, you're also going to install anything that may have any kind of dependency on that particular package. So make that as a habit, even if if it is already set for you in the newer versions of R, which wasn't the case before. The other command that is also available is require, and once you type in require, by default it just returns a warning. It will not give you any error. When you use the library command for any package that's that name is invalid or you have never installed it, it will give you an error back by default. But the default behavior of require is that it just gives you a warning. So that's the subtle difference between these two commands that you can use for loading your packages in the environment. Require is typically used when you are using functions and or trying to see if certain packages already installed and you want to just kind of load them, or if they are already loaded, you don't need to load it. And if there's any issue, you want to get kind of a return information. That's where require is typically used. Okay. Knowing more about the packages, there's some more ways here. As I've mentioned, there's a help that you can use with a question mark. The other way is to kind of type in the library and help is equal to the package name. It will open up some package, some documentation that's available for that particular package. You can also, open up the vignette for a particular package. You just type in the command vignette and tm. It will open up the vignette for that. You can also have a vignette, displayed on a browser. You can just type in the command, browse vignette, and give the package name within it. It will open up the vignette in a PDF form, or a very nice web page on your browser. Okay. Next is, once you kind of, know and about the versions, about, which packages are installed and how to load a package, very important, because, we've seen in the past where, folks, whenever they wanted to use, load a particular, package, they always kind of put up an install command. So install is just to be used once in a particular version of R that you have. We just need it once to install it in your environment. Once installed, you always go with the library or the required command to load it in your environment, because that is already available for you. Okay. The other thing is to check for the package updates. If you got installed on the package today, as I said, every day there's some updates that are going, especially some of the packages that are very popular packages that are people working on and kind of really updating those packages. And sometimes you need them, right? They may have, solved a particular problem, or, they may have added some more features to it, which could be very useful. So, always try to update your packages, and there are different options. You can use RStudio, first of all, RStudio. If you go to Tools, and there's a menu option there, check for package updates. I use it all the time. I mean, every few days, as soon as I remember that maybe I've not done any updates for a long time, I would just go and check for package updates, and that really helps me to, first of all, I know that anything that I'm running and I'm kind of testing something, I'm testing it against the latest version of packages. The other option is in the Packages tab of the View panel, which is typically on the bottom right of your screen. You can see the list of all packages. There's a Packages tab. Right next to it, there's a checkbox, right? You can just click on that, and then on the top there's an update update button, which you can click to update your package. You can update one or more packages. So this way you can even selectively update your packages. The option 3, as I mentioned, you can just go and update all the packages by just typing in the command on the console. So these are different options where you can keep your packages updated. Now, there could be instances where you may want to kind of remove or unload the packages. Hopefully, you will not, I hope that you don't hit to, this kind of scenarios where, certain packages have kind of, not installed properly, or are not working for you, or you probably loaded some version that you really want to get rid of and do not have it in your environment at all. And one of the ways is, if you want to just unload and remove if it is required, you can use detach command for it, and you can say detach and the package name be like package colon let's say TM package that you want to, and then unload is equal to true. Unload the package from the current R library. You can just detach it, or permanently remove a package. You can just say remove.packages command. You can use it to remove that package completely, so that you can install it again. Okay. So just few basic things. I know you may have already gone through it, or you may be already using it, but they come in handy all the time, and this is something that is required, and things like updating your packages, very important. Sometimes they may also it becomes a negative experience as well, when some things could be working and all of a sudden you updated a package and it doesn't work. But guess what? I mean, it is helping you to kind of change things that may not have been correct in the first place. So it's good to update it, and then maybe you'll have to go back and change certain commands or change certain parameters that you have used because of the fact that they may have corrected an error, or maybe they may have made the package even better than before. Okay. Any questions here? Any questions from our perspective? Do you guys have any issues with installing the latest version of R or R Studio? Okay, so now we can just dive into our assignment details, right? In the assignment, all the different steps in the assignment. So as you know, the part one, you have an exercise to complete where each of the steps have already been listed out and it's been described very well. So it's basically to run those commands, and there's some basic description provided, and there are certain questions that you would have to answer. So your task is going to be to run those commands, make sure that you have the snapshots for some of the commands, especially if it's going to be a plot or a graph or whatever it is, maybe you would want to attach it. I saw that Professor Ilana has already given some more instructions by answering one of the posts on what should be the format of this paper and if the snapshots are required. And she did mention that she's going to look out for the snapshots for this commands being executed. What does that mean to you? So this part one is really going to help you to complete your part one is going to help you to complete the part two. If you understand all those different commands, if you know why they are to be run and what they really do, that's going to help you to go through your part two and pick any data set and run with and you analyze that data set. Okay, so that's the main theme of your assignment, to get used to text analysis, especially in R. And as I said, for that, maybe pick up a nice data set that you can get hands-on to. Maybe that's publicly available, or if you're going to use it from your workplace, great. I mean, that's something that it's a real-world kind of a data set that you're going to be using. Having said that, there are multiple places. You have probably seen many sites that have been published to you through different courses. Maybe you already have. I hope you could have saved them. So go look out for some data set that can really challenge you and can really help you to come up with some real nice analysis for your part two. So the basic steps here, so like the steps that are that you would go through for any text analysis is, first of all, loading the data set. Whether it's loading the text files, great. You're kind of using what you may use in future when you kind of go on to using some big data technologies. Is you're not going to get a data set directly on a CSV format, right? What do you do in that case when you want to really load? So this is an excellent exercise for you, kind of setting you up for those kind of challenges where on real world kind of situations where you would not get the data in a CSV format, but in a just with all the files in a directory, or maybe there are hundreds and thousands of trouble tickets that you may be going through in a particular directory that you have to kind of load it. So this is a very simple way. One command could kind of load an entire directory, all the text files or whatever the files that you may have in your directory. So that's your first command, loading the text files. And the package that really helps you to do that is the TM package. One of the most popular packages, has been around for a very, very long time. I don't even know how many years it has been, but it has been around ever since I know R. From past few years, this package has been around, and they're kind of adding it, or maybe even upgrading or updating this package ever since. So make use of this package. As having said that, it's not the only package that's available for text mining. As I mentioned earlier, go to CRAN. You may find some other packages that you may find it very, very interesting. There are very interesting packages that have come up that can be an enhancement. TM is a basic package that you would really probably use at every single time, but there are some packages that can enhance your analysis by giving you some more features and that can help you analyze or build charts, or see your data in many different ways. So it can help you in visualization. So there are some packages that help you with pre-processing of your data. There are some packages that help you to build certain graphs and things of that nature. So there's a huge a list out there that you can really make use of. Okay, all the packages. So first, after you've installed the TM package, which is the need for this particular assignment, you install, make sure that you have loaded it using the library command, and then you may want to set your working directory. In your instructions, we kind of mentioned that set the working directory to the directory where you have this file. One of the ways to kind of not get into that habit of going through or different directories and using this dot kind of notation or the dot operator, you can just create a variable for where your files are all loaded. This way you don't have to kind of know and get confused or find out where you are within your directory structure. You're just going to use that straight a variable, which is pointing to a particular directory, right, in your local PC. So you can make use of that. Then you can just get the list of your files by using the dir command. Very simple, right? I mean, we've used this in the past. We do this all the time, although we are using Windows Explorer. But I hope some of you may still remember some of the commands that we used in the past. So this way you can get a list of all your files that are out there. There are 18 files that are in that particular directory that you can, that you are going to be loading and going through this analysis. So the first thing that you would do is, after you kind of, check your environment with packages and versions and all that, and upgraded your packages, you're going to start, working on your, on your analysis now. And one of the features of the TM package is, building a corpus of all the data that you really want to analyze, or the text data that you want to analyze. So, first and foremost would be creating this corpus. And the creation of corpus is a very simple command where, you would just look at a particular directory, and this would just read in all the files for you and create an R object here, which is called the corpus. The corpus of all the text information that is available in all those 18 files. Very simple, yet so powerful, right? Okay. Next would be, to get a summary of, what's this corpus, what's in this corpus, to get a quick summary, like your summary command that you use in your data frames. You can use a summary on the corpus to, see, what, how many files are there, what's the type of files, it's a plain text document, and so on. So this kind of information you can get from a summary command. You can also inspect the contents of your corpus by, using the inspect command. If you've been using, the other ways of going through the corpus, inspect is the better method to kind of use for inspecting the different documents within your corpus, or inspecting everything that's in there in your corpus here. So make use of the inspect command as much as possible. Okay, so when you inspect it, it's just kind of giving you some metadata information, like what's the number of documents, and then it kind of starts listing each document name, along with that the contents of each document. You can also look at the length and the metadata of the entire corpus or each document within the corpus. So here you can just say, length of documents is going to give you the length of docs, which is the corpus here. It's going to give you the number of documents within the corpus. If you want to, list out all the metadata at the corpus level, you can just, type in meta, and, given the corpus, it was going to give you, in this case, we don't have much metadata. We haven't really created, and I'll kind of just go over with that quickly as to how you can even add your own metadata to your corpus, or to to each of the documents within the corpus as well. So let's say if you want to, go at the document level, you can, you can list a particular document by just saying, docs, and in two square brackets, you can use it, with that, you can use the subscript here, like 1 or 2, or you can go up to 18, and it's going to list out, what is, some metadata about each of the document here. You can also use the meta command here, which is going to give you some more detailed information. And as you can see here, there's some metadata that is already there by default, like author, the date timestamp, the description, the heading, the ID, language, and origin. So some metadata is already is kind of available for you to use, and they may not be populated with any information because there is no information in there, but there's still some information that you can make use of, like, for example, the ID and the auth ID field is basically is already populated with the name of the document. So you can use that, you can use, or you can populate with author. If you know the authors of each of these documents, you can update it here rather than creating a new column or a new field and creating a new data frame. So this is the way you can, since there is no data frame kind of an approach here, it's all corpus. There's a way that you can, use certain fields that are available within the metadata, or also there would be a way to kind of even, see what each particular metadata. I'm just kind of going into a little more details here, kind of saying, okay, now that I see everything in there for a document, how do I really go to and pinpoint to a particular metadata? I want to see only date timestamp, right? So you can just, give some more details here. You can use the parameters of, metadata function, where you can provide the document that you want to look at, and the other parameter value is going to be the name of the metadata, that tag that you're going to use, and the tag that you're trying to, get it displayed is date timestamp. So as you see, the output is going to be the date timestamp for that particular document. So this way you can, kind of go through multiple documents that, oops. So you can see through all the multiple documents for like document number 3, document number 4. You can look at all the different, the date timestamp of different documents. Similarly, like, if you want to add, as I said, like this metadata is so powerful that if you want to add, and then you kind of start doing different analysis, and you've got, tons and tons of documents. These documents could be, guys, this could be emails, this could be trouble tickets, this could be so many different things that you can think of. I mean, I'm sure you are all kind of started using or have already picked up a data set, and think of what could be a good metadata that could be useful, that can help you, with your analysis, especially when you're doing some plotting, some clustering, and you don't have like a good tags or for these document names. How do you come up with that, right? How do you come up with your own names for each of these documents? So this is one of the ways to kind of use the metadata feature and using different tags for yourself. Like in this case, I've created a tag for, called program. A program is data analytics, right? Want to add a tag called program as a metadata. So you can have a metadata at the document level. Similarly, you can also have a metadata at the corpus level. You can just, just give you an example here. You can say meta and give the entire corpus here instead of providing any subscript to pinpoint to a particular document. You can point to the entire, you can reference the entire corpus here and give the tag name and give the value for that tag. So all the documents are now going to have a metadata tag called text dash type, and it is going to say course information. So now when I type in meta docs, it's going to list out the course, it's going to list out the text type, and as you can see here, it shows the course information. It's being updated. So for all 18 documents, the text type tag has been added. One single command has helped you to kind of give an additional tag to your corpus and the documents there. Okay. Any questions on metadata? Okay, so let's move on to our next step, which is viewing your data, right? So now that we've kind of loaded things in Corpus, how would you kind of, display the contents of the corpus? So there are a few ways that you can do. Um, One of them is kind of already mentioned. You can create a data frame, um, and you can just just convert everything that's in this corpus as a character so that it could be displayed in a data frame form or as part of your data frame. So when you just give this command data.frame, what you're doing is you're creating a column called text, and which is just built upon as from the all the contents of the corpus, right? Each document within the corpus. So once this command is executed, you'll see that it will list all your documents with the text information within it, right? So this is one way of displaying your data. There are other also packages like you can there's a nitar package that provides you this function called cable, and it kind of gives you a nice way to list the same content. So just different formats, right? You can play around with, how best you would want to kind of get it displayed. What's the purpose of display in your document or in your analysis? So you can use it this particular form, from nitar package. You can even use the pander package to, and the pander command within it to list it in a little different way. As you can see here, it's been listed nicely as part of each document. It gives you like a nice readable format here for each single document. So just different ways of displaying the same data. Okay. So this is where certain knowing certain packages really help. I mean, these are different packages outside of TM, and yet they help you with some of your text analysis. So these are some of the supplement packages that you can search for or you can make use of for doing your analysis. Okay. So then let's move on to our next step in the process, which is data pre-processing. So in this case, so the first and foremost, so you're going to go through a list of steps here, right? So first and foremost, you want to get rid of all punctuations and special characters. So there are certain commands, there are certain functions that are directly available as part of the TM package. And there's a way that you have to use the function, like there's a TM map function that you can use by, your first parameter is going to be your corpus. The second parameter is going to be the name of the function. So you just give that. In this case, you want to remove all punctuations. So you remove that, and then you can use the data frame or whatever you want to make use of to look at the contents of it. What changes did it do? It took away all your punctuations that were there, all the periods, the commas, the colons. As you can see here, they're kind of all gone. They're no longer there in your document because they really do not add any value to your analysis. They're really not a requirement in your analysis, right? Unless it was like more like an NLP or natural language processing where you may need some of those punctuations, but in this case, you really don't need it. Now, there are certain special characters that you may also want to remove, and there's a way here, kind of, as you can see here, you can also create your own functions where you can just give any pattern that you want that need to be removed. Patterns like @ or a pipe sign or a slash that you would want to get it removed, which there's no standard or direct function provided. The punctuation is probably not going to remove these characters. They're not part of your punctuations or any other commands for that matter. Okay, so this way you can run some special functions or run the given functions that you already have as part of the package, and then make sure that you inspect at least one or two documents to see that what you were really looking for to do is has been executed well and no issues with it, and then go forward to the next step, which is removing the numeric characters. So in this case, you would remove the numbers from the data. Once again, they really do not add more value to it unless your analysis really demands it. In this case, we are removing the numbers, and once you inspect a particular document within the within the corpus, you see that all the numbers have been now removed. So that's the next step there. The other step you really want to take now, as you kind of move on to, kind of cleaning it more and more, that now we want to kind of make sure that you're converting it to all lowercase. This is one of the important steps here, especially if you are going to be counting, the words, how many times they've been repeated and how many times they have been, if you're going to build that kind of do that kind of an analysis, you want to make sure that all your words are in a particular case and in one single standard case, and not in different ways that it could have been put up in the document. So you have to be careful with that. So make sure that you run this command here as part of your cleaning process. Next step is the stop words. Words like a and the, and once again, you're using, in this case, you have to give one additional parameter called the stop words. Now there are two ways. I mean, in the document, it has also been mentioned in the assignment instructions that you can use smart as one of the parameter values to stop words, or you can also use English. See that most of the commands, or most of those words, are no longer part of your documents, like a and the, or any other words that you've been really looking for. So here I've just made use of smart. You can see if it has really done the job for you. If not, you also have a way to kind of go back and and add English to it. You can also create your own stop words here. You can add more stop words. Let's say I want to remove techniques, concepts from this particular, all the documents. You can add to those stop words. Along with smart, you also want to remove fundamental. You want to remove concepts, and it will all be removed. Let's say if these were the words that are being repeated often. Maybe data is one word that's repeated so often that you think it's not going to add value to your analysis. You can add it to this list here, and then this way you can get rid of all the words data that is out there, right? Or any techniques, any word called techniques that's out there, you just get it out of your document. So you can play with that and see which are all the stop words that are that you really want to get them cleaned out from your document. Next step is stemming, and stemming is also an important step, and there are a couple of ways, a couple of packages and also the techniques that have been out there. TM package provides you the stem document function that helps you to get your word to the root form, which is like if you have a word which is running and run, or learn and learn, you have those eds and s's, that you want to kind of make sure that you bring all the words into its root form, so that you know how many times they have been repeated in different forms, right? So that's this stem document really helps. Now, one of the things that you would see, and I'm sure some of you have already gone past this step, and you may have noticed that your words get cut down at times. And there are also techniques to get those words back to its original, really root form, right? Some of them come with I as an extra there. Some they just cut down that it really doesn't, sound correct, or it doesn't appear to be correct at all. So you can even just go and update, this again. There's a function stem completion that you can apply, or create your own dictionary of words that you can apply your corpus against it. And just you can play with that. That would be not required for this assignment, but something that you may want to research or work upon or try, which will help you to get these words back to its at least to its original root form, or a root form that kind of makes sense to you and for the analysis. Okay. So the next step is document metrics. But let me ask again. Let me stop here and see if there are any questions up to this point. So one of the questions I just got was, I did stem completion and it did not work in 3.4. Okay, let me see. trying to read through all of that. Okay. Okay, the inspect command truncates the text. Is there a way to avoid that? So that's one question. The inspect command, did you try with the, I mean, is this the inspect with the, for a particular document, or was it the inspect for the entire corpus? Could you please type in that so we can try to address it? Second question that I see here is, it tried completion and it does not work in version 3.4. Yes, I know that even in 3.3, it gave some issues, and particulars, and sometimes I think one of the issues that I'd also noticed was that it took a very long time in on my PC. I mean, it really took a long time. Of course, I had a very huge data set also at the same time. My corpus was really huge, but it did give me. So one of the techniques that could also be used in other than STEM completion is building your own dictionary of words, or using a standard dictionary that's out there, and then do a spell check. That's one of the techniques that I recently also used for one of the real data sets, and it kind of that kind of really worked, because it helped me rebuild these some of the words which did not sound right. So you could do like a spell check, and the spell check is really helping you. I believe there's a package called spell checker, or a spell check package, and you can just check it on CRAN, and it helps you to check your spelling and correct your spelling of your certain words. And it has got a good dictionary. I mean, it's already having lots and lots of words. Maybe there could be certain words that are very, I mean, they're just applicable to your domain, and which may not be very common or popular. Maybe you'll have to add those words to your dictionary. But otherwise, you can just pick any dictionary that's available out there, and use that package. So try using that package if you want to. Okay, but once again, it's an add-on to it. So you may want to just use it at the point when you kind of gone through your assignment, and because still in this form also it's still correct. So your analysis is not going to be wrong. It's just that kind of giving you some way to, and if you're going to do like a presentation, let's say at your workplace, and you don't seem that these words are correct and want to kind of correct them in some way, then this would be a way to do. Okay. So I think Divya just mentioned that the text file we are using in part 1 is even larger than what the inspect command does. And is there a way to kind of increase the width of it? I mean, increase the contents of the text file. So I don't know if the width command, that I think there's a display width in the options. So maybe you want to try, Divya, with the options. There's a function called options that will list all the different settings for your R environment, and you can check what is the display width that for the data that is being displayed. Anyone else have seen this problem, or have worked on this problem, and you have a different solution to it? Okay, I'm hearing none. So Divya, maybe you want to try with that, okay, and let us know. All right. Okay. Sorry, guys, I had to kind of jump around this document in between because it just had to reload the page from the Shiny. So yeah, I mean this particular I think this document is created using R. As you can see, it's using the Shiny package and the Shiny server. So one of the ways how you can kind of make some interactive plotting, as you can see, it would be more useful when we get to the charts and graphs, where you can play around with certain widgets that are kind of available through Shiny. So this is all done in R. So whatever you see here, and what you'll see in kind of going further also is all done in R. So it's just one of the things that you may also want to kind of pick on, maybe whenever you get time and want to kind of explore R even further. Okay. So once you kind of have gone through the cleaning and pre-processing of your data, the next step is the creating a document term matrix. It's kind of laying out your corpus in a matrix form with rows being your, so there are a couple of ways you can do that. One is using the document term matrix. The other is the term document matrix. And the difference here is that document term matrix, puts all your data, the document in the row form, and all your words or the terms as columns. And the transpose of this is the term document matrix, meaning your rows are your terms and the columns are the documents. Okay. So once the document term matrix is formed, as you can see, you can just type in the document matrix, that object, and it will give you some information about this object, like number of documents, number of terms that are found in all the documents, and the sparsity of it, like how many cells how many total cells are there in the matrix, how many of them are having the value of the frequency count as 0, and what is the overall sparsity of your matrix, and so on. So you kind of get that, and this is term frequency, which is the weighting that is being used. So there are a couple of other weightings as well that you can, probably you may have already worked in the past, but if not, the other type of weighting which is also popular is the TF-IDF. So maybe you want to just, check on that, research on it. If you've never used it before, if you've used it, that could be the other way to kind of use the document or create a document term matrix with that kind of a weightage or weighting. So once you kind of gone through that, the other would be to create the word frequencies and associativity. So the first is, knowing how many times a word has been repeated, or what's the frequency of each word within all these different documents there. So you can create the call sum. There's a call sums function that will kind of help you to get the frequency or get the the column and the sum of all columns, which is nothing but your terms, right? So you're getting the sum of columns and you're storing it into a variable. And then when you want to find out the total number of terms, of course, it's going to give you 315, and frequency is going to give you the frequency of each of these 315 terms in your matrix. You can also, order your matrix, which I think this is also the other steps that are listed. So you can, play around with that a bit, but, you can order your frequency in the way that you would want, in ascending or descending order. And then, just look at that matrix. It would be like a true matrix. You can convert it into a true matrix and look at, different rows, different columns. And there's just some way here that you can, browse through your matrix here. As you can see, you can give this kind of notation where M is the name of the matrix here, and you can give the number of rows, number of columns. As you can see here, this particular command here is going to list 6 documents, so 6 rows, and then 6 columns, which is nothing but your terms. So just giving you a way to kind of look at different documents here and the first 6 terms within these documents. Okay. You can also see with with terms with minimum frequency. So if you want to find out which are all the terms that have been at least repeated within these documents 5 times, you can use this parameter called low frequency, and you can pass value to it, and you can see the words here which are listed. Now you can also go through it and see which are how many times the certain words which are your top words, or which are the least words, or the words that have been so common across all your documents. So if you keep increasing the value here of low frequency, you can see the list kind of changing, or you can just decrease it, or you can increase it to see which are your most popular words that has been common across documents, or words that are very kind of rare, or they are not used very frequently. So you can see both ways and kind of come up with your own list of words based on what type of analysis or what you really want to show it here. The next is removing the sparsity. As you saw that it was kind of a very sparse matrix. So now you want to really cut down on the terms. You really don't want to carry all your words, which especially if they are not really being used much, through all the different documents. Maybe if you want to remove them, one of the commands that's available is remove sparse terms. And this command will help you remove terms, by giving a certain threshold. Like in this case, you're giving a threshold of 7.7, which means removing kind of terms that are, not covered by at least 70% of, or not within 70% of the documents, right? So this way you can, remove the sparse terms there, and kind of, and if you look at this particular document matrix, you would see that this document term matrix has now shrunk to, it still has the 18 documents, so that's not going to go away because you just remove the terms that were, not, that were like at least, that were available in more than 70% of your document. So now there are only 19 terms that are available in more than 70% of their documents. And as you can see here, you created the terms, only 19 of them are remaining. So this way you can, kind of reduce the sparsity within the document term matrix. And this could be, useful. This is one of the very useful steps. And there's no standard, and I would not kind of say that, 0.7 or 70% is standard. It depends on the analysis, depends on what you really want to do. In fact, you could even go up to 95% or even more or even less, depending on which way or how many terms you've already found in your first analysis. Maybe you would have got like 30,000 words. In that case, you really want to cut it down, right? Because now your analysis or further use of the commands is going to take a very long time. So you want to really play around with the sparsing of your terms, or what sparsity that you really want to use for your document term matrix. Okay. Same thing with your associations. You want to find out which words are really have been together. So there's a comment from Kurt that you went up to 99% and you still had many words. Yes, try to go above 99% or go below 99% to see that, if this is the threshold that you use. If you cut down on your threshold, so you're going to say that, give me the words that are covered by at least 70% or at least 80%. Then you're kind of going to, see more and more words that are going to be out of your, or reduced from your matrix, right? So you have to play around with those, with that threshold, based on your data set. Same thing with your finding associations. If you really want to find out, how data has been used, or how analysis, or how methods or mining, what are the different words that have gone along with these words most of the times. Let's say, and in the correlation that you kind of put up a threshold of 75% here, or 0.75. And you can play around with this also, right? Once again, this threshold is not set in stone. You can check with different thresholds. Let's say the threshold of almost 0.5, how is data really related with some of the words here? As you can see, data and action, they kind of go hand in hand a lot. Data is got the correlation with action word is 0.75. Very similarly, with the word include, or including whatever it was, like this root form include, it has been correlated with as 0.49. So may not be as frequently as data and action, but it has been also used with data quite a few times. So you can play around with what your correlation limit that you want to set for, and see how your certain words are being used, along with what are some of the combinations of words that have been used within your corpus or documents. Next is plotting, right? You want, besides just having this analysis in a text form, you want to really see it in a more visually, right? Because visually is kind of very important. Sometimes, when your corpus is large or your documents are too many, the text information is not a good way to kind of present your analysis. So there are certain charts that kind of are really helpful. One of them is the correlated, terms that you can use this chart to kind of see, these correlations in forms of a different graph here. Certain words that are kind of used in combination, focus and examine, or make and practice, or make and you know, so this is decision, yeah. So make and decision, the root form of decision. So these are different combinations, and it's based on, once again, you see as you change the threshold, this this relationship is going to change accordingly, and it's going to show accordingly. So you have to set this threshold as per what you really need to do, and once again, you're not using the entire data set here, using just very few words, because if you use all, maybe you can use all 19 words and still get a better graph, but it depends on you may want to pick your top words to see that this kind of an association with those words, or there could be some special words in your document or in your corpus that you want to see the associations with. You can also see this graph can also be used along with by depending on the relationship. You can see as the lines are kind of thicker or they are thin. So this way you can see that make and decision is kind of used more often. That the associativity between these two words is much stronger than what you can see with manage and practice or manage and examine. I think that those two words are not that highly associated than make and decision. They are kind of really strongly associated, as the words like make and practice. They're also kind of strongly associated. Okay. You can also make use of the bar plot, and this bar plot helps you to list your words with, and it's a simple plot here to kind of show you as to what's the frequency of certain words in your document. Once again, not a good chart for if you have like 300 or 400 words. You'll have to really cut down the dimensions here a bit to kind of just come up with few words that you can display here. One of the charts that is often used, and it's become like a fancy thing these days to kind of put it in a word cloud form. It's good for just some quick visualization, but I don't know. I really sometimes I find it questionable to really it's useful for analysis, because it's not really giving you much information except for kind of a quick visualization of what could be used or what is used more often. Data is used more often. Yes, we all know that, right? But yes, this is kind of a quick, if we want to kind of quickly look at all the words within the corpus that you have, this will be one of the quickest way to find out which are some of the words in your corpus, which are some of the words in a certain documents, and and what's the frequency looks like. Like from this, you can quickly say that yes, data is going to be your topmost word. Database, include, manage, and system are some of the other words that are kind of repeated more often. So once again, you can change the minimum frequency here to see less and less words or even more words accordingly as to what kind of frequency you want to set. So as you can see here, this word cloud has been formed using a certain minimum frequency of 2 words. That was the kind of a default that we started with. So it was almost on the left here that we started with. And we can go further. We can keep changing our frequency. So just using some of the shiny features here to kind of see my plots in different ways at different frequencies. Finally, we see that there's a clustering that you will want to kind of you'll have to do the clustering as part of this assignment, and also could be required for the part 2 of your analysis. So 2 types of clustering: the hierarchical clustering, where of course after you, in this case I kind of removed the sparse terms. I went up to 0.8 because I wanted to kind of see some more words and into my analysis here or in this particular cluster. So when you do the 0.8, it kind of came up with 45 terms. So more than the 19 that we had before. So that may be helpful. So that's kind of a little prep here that I'm kind of doing for hierarchical clustering. Then you can, as there's one of the commands, there are a couple of commands that you use to create your cluster dendrogram is, finding the distant matrix here using the Euclidean method, and then use the hclust command. So this forms your cluster dendrogram here, as you can see, is all these words. Only issue with this cluster dendrograms, guys, is that if you have multiple words, many words, it really doesn't come out very well because it gets very clogged. It doesn't give like a very good output. But yes, if you have words like as I use only 45 words out of this entire corpus, then maybe I'll be able to see some use see some visually see the clusters here. Um, can anyone tell me like how many clusters, if you had to kind of figure out the number of clusters from this particular dendrogram, how many clusters would that be? Anyone? Any guesses, or anyone kind of know how you would find the number of clusters just by looking at the dendrogram? Just an idea, just a thought. Any guesses? Come on, guys, I won't hold you for that. Okay, so Divya started that. Thanks, Divya. Started with 6. Does everyone agree with Divya? Does anyone have a different number? Okay, Divya went up to 8. Okay. Kurt is saying 9 clusters. Okay. Anyone? Any other number? So people think either 6 or 9. I'm sorry, 8. Sorry, Divya changed it to 8. Oh, okay. Courtney comes with 10. Whoa. All right. Anyone beating 10? Okay. Akin is again 10. All right. Okay. Anyone else? If not, then I'm going to say that 2 clusters. Sorry, Richard. I just saw your your just chat window now that you just typed in that you wanted to probably also participate. Sorry about that, but is there any other questions beside this, Richard, that you wanted to or you make a comment here? Okay. All right. So the reason I would say 2 here with the cluster dendrogram, as you may look into this little more, but the way to kind of find out the number of ideal clusters in a dendrogram is look at the tallest distance here, the tallest, which is the tallest tower here, and the vertical towers here. And the vertical tallest are these 2 here. So if I have to draw a vertical line here, if I have to draw, I'm sorry, the horizontal line here, I will draw in this tallest buildings here. And the 2 tallest buildings that I can see here, tallest meaning from the point that, in this case, it's like around the point of, I think, around 12. So this is where it starts. This particular building starts here. And if I have to just consider, this is the tallest amongst all buildings coming from, this, from then they start. So this is the base. From the base of the building, which is the tallest one, and this is the tallest one here. So when I draw a horizontal line, I will draw a horizontal line here. So technically, if you have to just go by with the 45 words that we used, there'll be only 2 clusters, ideally. Yes, you can make more clusters, and it may still show up, but I'm just saying that ideally, they were part of 2 clusters. And we'll see how you can find, even using some other techniques as well, with these clusters. But now you can give another function here, use another command by say that when you put k is equal to 4, it is going to just draw this based on whatever you give. You can give your 6, you can give your 8, and it will try to create this red boxes. This red boxes is just based on what you give the number here. It is not going to just paint it by with with kind of going through the analysis that we just went through by finding out what is ideal number for the number of clusters here. Okay. So the other way here, so one is this dendrogram, but once again, as I said, not too popular when it comes to a lot of terms, because this becomes like a huge chart or a graph that could be a little messy and may not be very helpful in the entire analysis, but still one of the techniques here. The other technique that is very popular or are being used a lot is k-means clustering. Once again, in this case, the prep is that you make it 0.75 and kind of use the sparsity to 0.75, and then create a cluster plot with 4 clusters. In this case, I went with 4 clusters directly by giving the value 4 to k-means, right? And then use this function called clustplot. And as you can see here, a bunch of terms that go into this first cluster, few terms that are going into your second cluster, and in this red cluster here, there are some 3 terms that I can see here, and there's 1 term which is in the only cluster, the fourth one, which is kind of so far off. So let's see how it comes up with 3 clusters. So when you change this k-means and provide this value 3, now the same data is shown in the 3 different clusters here. Once again, the first one is very crowded, the second one less crowded, and the third one with a solitary word in there. But this way you can look at the word. Now, how do you really come up with the best right value for k? And that is with the use of elbow and scree plot, which is also kind of a popular technique to find out what is going to be the base or the best value for k or the clusters. So the way you do that is use something called between sum of squares, and so there's this technique or it's also been described in your instructions, but it's between cluster sum of squares or within sum of squares. So you would use that to kind of go through your k-means function multiple times. Like in this case, you are going through this, taking the value of k as 2, starting with 2 and going up to 15. You're using, or you're just executing the k-means function, and then what you're going to plot is this between sum of squares. So you can see this BSS, which has been, so this is the value of your BSS with the, on the horizontal axis is the value of k, and on the vertical axis is your sum of squares. And as you can see here, this blue graph, which is nothing but your between sum of squares, that has been plotted. And the typical way to find out the number of k, which is going to be ideal, is at the point of an elbow, like the elbow point here. The point where your graph kind of moves out of the, or kind of changes the trajectory, is the one that you want to make use of as the value of k. And of course, you can try with other points as well, but that is going to be probably the ideal one. So as you can see here, with the between sum of squares, your trajectory kind of changes when it hits to this number 2. You can also say that the trajectory is like, this is, if you kind of visually look at it as like a hand, then this is your elbow here, this elbow part here. And this elbow here is telling you that, hey, maybe it's not 2, maybe I can try with 3. And you can see what clusters you get. Do you really get distinct clusters, or you get clusters that go into each other or run into each other, right? So this way you can check with different values of k and also find out what value of k could be applicable to your cluster. The same way you can also use within sum of squares, and a very similar plot, but it's in like a different direction here, as in it's more in your the very close to the horizontal axis here. And as you can see, once again, if you're going by the trajectory, it's either going to be 2 or 3 that you can take the value for your cluster. Okay, but once again, with the dendrogram, I'm not going through this plot here and kind of mention about dendrogram, but that's the way, because when you're going through just by the dendrogram technique, that's the kind of technique you use to kind of see where you can cut your building, which is the tallest building that you can cut horizontally is going to be a number of clusters. But that's a visual technique. This is a more mathematical kind of a technique to find out your number of clusters. Okay, any questions? Okay, folks, won't take much time here, but just 5 more minutes to kind of quickly introduce you The topic modeling, which is an add-on, it's not part of your assignment. Do not expect it to be part of your part one of the assignment, but you can make it as part two of the assignment. This is a topic that can have its own. We can go through and then spend like an hour or even more than an hour in this particular topic. But kind of just quickly introducing to you, and you can go through it a little more. But it's something called finding topics within your corpus or your documents. And it's very powerful, very useful, used a lot. There's a lot of research also going on in this area, especially when we are into processing of emails, into processing of different trouble tickets, so on and so. There are many things. You look at social media, you want to find out the different content, like different topics that are being discussed in social media. How do we really get to know that? Or how do we know without even looking at the data set or without knowing much about the data set? How are you really going to come up with the different topics here? So one of the ways is the technique that's available here. So before that, a little prep here to get our data in some form. And what we are trying to do here is trying to see that we get the documents that have at least one term in there. We don't want any documents that's not having any of the terms. Based on the sparsity that we have used so far, we want all documents to have at least covered by one word, right? So that's what we are checking here to make sure that we are still going to have 29 terms here based on the sparsity. We are going to have 29 terms, and each of the documents, or each of the 18 documents, is going to have at least one term. That is, at least one of the columns is going to be having a value more than 0. So that's what we kind of need to do as part of the prep. And then there's what you're using here is something called latent Dirichlet allocation. One of the techniques that's been very popular, and as I said, a lot of research going on. And it's a topic by itself. Like it could be a subject by itself, I could say. That's how huge this is. And then you'll find a lot of documentation around, and you'll find a lot of information on the web for it as well. So all you need to do is just use the LDA command here and give your your document term matrix. Make sure that each of your document has got more than one term in it, and there's a couple of methods and a couple of parameters that you can use. Of course, I would not go into each one of them, but you can just find out like what each of these, there are certain parameters that are by default required, and there are certain others that could be used to fine tune your, topic generation. So once you kind of have created your, once you've run this command, it creates, and here you're giving the value of k also. Once again, you can come up with your own value of k by going through like a scree plot or an elbow plot, which you can use the same information from there and plug it in here, or you can provide your own k, just by knowing maybe there are like 10 topics people are talking about in media. Let's give k as equal to 10, or let's give k as equal to 4. And then what you can do is find out the different, each of the words. Oops, wrong time. So you can basically find out all the words. So here in this case, we give the 5 topics. So you can list the different words that are part of the 5 topics. In this case, I'm saying just show first 5 terms of every topic, and it will just show 5 words. You can increase the number of words that can be displayed under each topic, and this will help you to trim down your either the topics or even increase the number of topics. If you see all the words kind of getting mingled in different topics and coming up showing up in more than 2 or 3 topics, then maybe your number of topics is pretty high and you may want to cut it down. So kind of you can play around with the number of k based on what topics, but these words kind of may give you some idea, especially if it was like a social media data. You could probably find words that are more for politics, regarding politics, or regarding sports, or so you probably get that nice clusters or segments of words that would kind of go and be part of a certain topic here. You can then kind of find out the about the the frequency of words about the topic. Like in this case, kind of just listing out for each document how many the terms or frequent terms were there, and what is the topic for this particular document that has come up based on different words that are used. It comes up with, hey, data 610 is probably for topic 2, or it's kind of can be referenced as part of topic 2. Data 620, topic 4. So you can name this topic based on the type of words that you see. So you can also, come up with your bar plot here for different topics, what the total terms are, like how many terms. Like as you can see, topic 4 was the most dominant one with maximum documents that are part. I'm sorry, the title of this should be changed to total documents per topic. So that's what it is. So kind of make that change. But it's basically showing what are the total documents per topic. We can also plot total terms per topic as well. But in either case, the topic 4 is going to be the most dominant topic, and then the others kind of follow. Topic 2 and 3 are almost at the same level at number 2. Number 3 is topic 5, and the least documents here, there are only 2 documents with for topic number 1. Okay, so this way you can also do some plotting here against your, and also there's a density plot. If you are familiar with the density plot, this is a nice plot that you can get for where on the x-axis you can have total terms in topics, how many terms and how many documents are there that are covered by this topic. So let's say this is this purple topic here, which you can name it the way you would want, like topic 5. Topic 5, as you just follow this this particular density plot for topic 5 here, which is all purple here, it's kind of showing you that what percentage of documents are having 10 terms in it, and they are part of topic 5. So as you can see here, there are 10 terms, maybe around 25% of the documents covered with 10 terms in this for this particular topic. Then there are less than maybe around 10 or 15% of documents covered by terms, topic 5 terms, like almost 15 topic 5 terms. So this way you can get like almost, and this is like the whole 100%, and you can kind of just see as to how your topics have been covered or spread out. So this is just one of the plots. I know kind of went through this very quickly. Maybe we could spend time, but I just wanted to just have this added in here as a bonus for you guys to that you kind of be here for this webinar. So just wanted to add something that could help you for your analysis for part 2. Okay, but feel free, if you've already done this in the past, great. This could be just a refresher for you. But if not, just look more into it and see if you can add it as part of your part 2 analysis. Okay, so we can call it a wrap now. It's pretty much we've covered what we wanted to cover today. So let me now open up. So I've got one question from Jason about plotting. Oops, let me go back to that question. I have a question back to plotting. When I create plot, I'm not seeing x-axis. I'm not seeing axis labels. I'm just seeing 2 lines. Am I missing something to have axis labels? Yes. I mean, it depends on which plotting environment are you using. If you're using ggplot2, then there is a way to kind of have the text labels. There is a parameter, or like I would say you can use a parameter there within for ggplot2 that can help you. Like as Ilana just typed in, there's a par command that you can use along with your ggplot2 command. Okay. I saw. Let me see. Go back to any other questions. Okay. All right, Jason. So for part 2, we can use the .csv file, which is a text column which I'm trying to analyze. I've already successfully loaded the data and converted into a corpus. Okay, cool, great. That really helps. That helps too. But as I said, many a times, as in real life, data or in situations, we don't get the data in a CSV form. So it's just kind of one way of showing how you would kind of work through those kind of situations. Okay. Let me see if I missed any. Doesn't look like, but maybe Elena, we can open up and just unmute everyone to see if there's any questions, any other questions.
If I mute everybody, then you know what's gonna be? It's gonna be echo.
Oh, yep.
So I think they can unmute each other. And let me know, guys, if you're still trying to find the data set, because I have a couple nice options there that I could suggest. Yeah. So I do have something in mind. If you're still having trouble with finding the data set, and I'm looking for that link right now, I'll find it. Because there is nice data set, it's on opinion data. There we go. So let me copy and paste link in the chat. This is a good one. It's a collection of opinions. Well, I mean, I'm just giving an example. But part two, well, I just gave an example of something that could be used, so to speak.
Okay, it's pasted in the chat window. You can
Yes,
see there's a link provided there.
I mean, what's question? Somebody asked if you could use a different data set. Well, you have to use a text mining. You need to analyze text for this
As long as
assignment.
you get text data,
Right.
you should be okay. Whether you find it in a CSV form or it's in files or in emails or whatever way, or in PDFs, whichever way you can get. But it should be like a text data because we're analyzing text here.
Mm-hmm.
The question is, do we need to attach the snapshot for each question? Yes, the snapshots are required, especially for, I would not say like every command that you want to paste a snapshot, but maybe the commands that you can probably mention. But if there are snapshots like plots or graphs that you want to show, and it has to be in part of the appendix. Most of your diagrams would kind of go in appendix, like if in case you're just referring to them, then Professor Ilana can kind of just look at the plots to verify anything that she may want. But your analysis could be just in the main paper. I mean, the analysis is important, but your charts equally are, and you can reference them in the appendix. The other question I see is how big of data set should I use? I'm analyzing Twitter text and covers 8,000 files. If your machine can analyze that, go ahead. I mean, that's absolutely fine. I don't think there's a limitation on any data set that you can use. It all depends on whether your local your PC infrastructure or your PC setup can really hold that and help you analyze that much of data. Yeah, you can just limit it to first 20,000 tweets or 2,000 tweets. That's fine too, but ensure that you have got enough to kind of come up with some analysis. That's all I would say. Yeah, movie summary is also good. I really like that, Yelena. That's one of the popular ones out there, which will kind of help you if you're doing some topic modeling. You can also find different topics, or sometimes even just using some social media data set if you can get hands-on to, where you can build those different topics from just looking at just the text data. Emails is another, Enron emails is another good data set that you guys want to make use of. I did it for one of my assignments when I was going through the program, and I kind of loved it. I mean, it's very interesting, and it was challenging as well. As we went deeper and deeper, you'd want to kind of get into it. But as I said, um, this particular assignment is not to doesn't have a lot of time to go deeper, do some deep dive, and do some complex analysis. But as long as you're able to go through all the processing that needs to be done in a timely manner, and some good reasonable analysis. Can I use PDF files? Of course, yes, you can, as long as you're able to read text data from it. Feel free to use. I think there's a package called PDF tools that can help you to parse through your PDF files. Okay. Any other questions? Okay, Elena, I don't see any, so I think we can call it a wrap.
Questions. I mean, when nobody asks questions, Lini starts asking questions.
Yeah, and if Elena starts asking, that's even more trouble. Is everybody doing okay with the assignment? No pain points, so there shouldn't be any questions now on the discussion board, right, Elena?
Yeah,
Because there are
right.
no questions.
Well,
I know. I'm just kidding.
then I start typing them in. What's the main text mining package that we discussed today?
All right, I see that as a question coming about Kaggle competition.
Yes.
Oh, okay. So yeah, what's the question about Kaggle competition? I mean, I did ask for the whichever emails I got from you all, like if you had non-UMUC ID that has been kind of you've been using, then I just asked for your UMUC ID, and many of you gave that and passed it to me. So whatever I got until this morning, I believe I have kind of sent an email. That should have been email come to you. How do we get to the instructions? That once you get into the email, it should take you to the competition page. If it is not doing that, let me know. I can make sure that I can even send up a link to that competition page. But it should really do that. I mean, that's the purpose of the email that gets actually automatically generated by Kaggle once I kind of invite you for this competition. So all that information is on that home page. Like once the landing page is kind of giving you that information that I had kind of gone through briefly during our first webinar. So if you can't get to that, have issues with it, let me know. I will kind of post a link for this straight landing page. Okay. All right. I don't see any other questions. Okay, Elena, we can probably call it a wrap now.
Unless there are questions. Well.
I don't see any being typed.
All right.
Okay. So thanks everyone. And good night. And good luck with the assignment.
So I'm gonna end the recording.
Okay. Thanks, Elena.
Sure.
All right. Okay. Bye, everyone.